Maps in Go. Question: how can you create a map in the Go programming language? Answer: there are several ways to create a map in Go. First, you can declare a map using the var keyword, but this creates a nil map that will cause a program crash if you try to add items to it. Second, you can create a map with initial values using a map literal, like a map with names and scores, and make sure to put a comma after the last item. Third, you can use the make function to create an empty map that is ready to use, and you can also give it a size hint if you know how many items you plan to store. Fourth, you can create an empty map using empty curly braces after the map type. Question: what is the difference between a nil map and an empty map in Go? Answer: in Go, a nil map is declared using var but is not initialized, and an empty map is created using curly braces or the make function. Reading from a nil map is safe and returns the 0 value, but writing to a nil map causes the program to crash. An empty map is ready to use for both reading and writing. Question: what types can be used as keys in a Go map? Answer: in Go, a map key must be comparable, meaning it supports the double equals and not equals operators. You can use bool, all number types like int and float, string, pointers, channels, and arrays. You can also use interfaces if the value underneath is comparable, and structs if all their fields are comparable. You cannot use slices, maps, or functions as map keys because they are not comparable.
Question: what are the basic operations for adding, reading, and deleting map entries in Go? To add or update a map entry, you use square brackets with a key and assign a value. To read a value, you use the same square brackets, which returns the 0 value if the key doesn't exist. To check if the key exists, you use the OK idiom, which gives you a second Boolean value. To delete a key, you use the delete function, which is safe even if the key doesn't exist. In Go 1.21 and later, you can use the clear function to remove all entries from a map. Question: how do you loop over all items in a Go map? To loop over all items in a Go map, you use the range keyword in a for loop. You can get both the key and the value for each item. If you only need the keys, you can use just the key variable. If you only need the values, you can use an underscore to ignore the key and get only the value. Question: is the order of items fixed when you loop over a map in Go? No, the order is not fixed. Go intentionally randomizes the order of map iteration. This means each time you use a for loop with range to go through a map, the items may appear in a different sequence. This is an important thing to know for interviews. Question: how can you loop through a map in a sorted order? To loop through a map in sorted order, you first collect all the keys into a slice. Then you sort that slice using the sort package. Finally, you loop through the sorted slice and use each key to get its value from the original map. This way, you get the map items in sorted key order.
Question: how can you loop through a map in sorted order using Go 1.21 and later? In newer versions of Go, you can use the slices and maps packages to make this easier. First, use maps.Keys to get all the map keys, then use slices.Sorted to sort them. Then, loop through the sorted keys to get each value from the map. Question: is it safe to change a map while you are looping over it? It is safe to delete items from the map while you are looping over it. Any key you delete will not appear later in the same loop. However, if you add new items to the map while looping, there is no guarantee that the loop will visit them or not. Question: what happens if you try to read a key that doesn't exist in a Go map? If you read a key that doesn't exist in a map, Go returns the 0 value for that type. For an integer map, this means 0. This can be tricky because you cannot tell if the key is missing or if it exists but has the 0 value. To check if a key actually exists, you must use the OK idiom where you get a second Boolean value that tells you if the key was present. Question: how does Go handle maps when you pass them to functions or assign them to new variables? Maps in Go are reference types. When you pass a map to a function, the function receives a copy of the pointer to the map's data, not a copy of the data itself. This means if the function modifies the map, the original map outside the function also changes. The same happens when you assign a map to a new variable. Both variables point to the same underlying data, so changes through one variable affect the other. To make a copy of a map, you can write a manual copy function that creates a new map and loops through the original to copy each key and value. In Go version 1.21 and later, you can also use the maps.Clone function. But be careful, both methods only do a shallow copy. This means if your map contains pointers, slices, or other maps, the inner data will still be shared between the copies. No, you cannot directly compare two maps using the double equals operator in Go. The only comparison allowed is checking if a map is nil. To check if two maps have the same keys and values, you can use the maps.Equal function in Go version 1.21 and later, or you would need to write your own comparison function that loops through both maps. No, maps in Go are not safe for concurrent use. If multiple Go routines try to write to the same map at the same time, the program will crash with a fatal error. To use a map safely with multiple Go routines, you need to protect it with a mutex lock. You can create a struct that contains the map and a mutex and use the mutex to lock the map before any read or write operation. For situations where you have many reads and few writes, using an RWMutex or read-write mutex is better. This allows multiple Go routines to read from the map at the same time, but only one Go routine can write at a time. When reading, you use an R lock for read lock, and when writing, you use a regular lock. This improves performance when reads are much more common than writes. Question: what is sync.Map in Go, and when should you use it? Sync.Map is a special map type from the standard library that is safe for concurrent use by multiple Go routines. It has methods like store to add items, load to read items, and delete to remove items. You can also do atomic operations like load or store, which gets the value if it exists or stores a new one if not. Sync.Map is optimized for specific cases like when keys are written once and read many times. However, for most regular use cases, a normal map with a mutex is simpler and faster. Question: how does Go implement maps internally, and what happens when you delete many items? Internally, a Go map is a hash table. It stores data in buckets, with each bucket holding up to 8 key value pairs. The hash of a key decides which bucket it goes into. When the map gets too full, it grows by adding more buckets, and this growth happens gradually during writes to avoid slowdowns. However, the map never automatically shrinks. When you delete many items, the memory used by the map is not released back to the system. If you need to free that memory, you must create a new map and copy only the items you want to keep, letting the old map be garbage collected. Question: can you directly change a field inside a struct that is stored in a map? No, you cannot directly change a struct field when the struct is stored as a value in a map. This is because when you access a map value, you get a copy, and modifying a temporary copy makes no sense. To update a field, you must either copy the struct out, modify the copy, and put it back, or store pointers to structs in the map instead of the structs themselves. When you store pointers, you can modify fields directly because you are working with the original data through the pointer.
Question: how can you implement a set data structure in Go? In Go, you can implement a set using a map with empty struct values. The empty struct takes 0 bytes of memory, so it's very efficient. You define a set type based on a map, where the keys are your set elements and the values are empty structs. Then, you can add items by storing them with an empty struct, check if an item exists by looking up the key, and remove items using delete. This gives you a memory-efficient set implementation. Question: What's a simple way to count how many times each word appears in a text? You can use a map with string keys and integer values for word counting. First, split the text into words. Then create a map and loop through each word. For every word, increment its count in the map. When you see a word for the first time, the map returns the 0 value, which is 0, so adding 1 makes it 1. This gives you a frequency map showing how many times each word appears. Question: how can you group items by a key using a map? To group items by a key, use a map where the key is your grouping category and the value is a slice of items. Loop through your data, and for each item, append it to the slice that matches its key. When you see a new key for the first time, the map returns an empty slice, so appending works right away. This creates groups of all items that share the same key. Question: how do you create a reverse lookup map in Go? To create a reverse map, you make a new map where the keys and values are swapped from the original. Loop through the original map, and for each key-value pair, insert an entry in the new map with the original value as the key and the original key as the value. This lets you quickly find a key by its value instead of the other way around.
Question: what is memoization and how can maps help with it? Memoization means storing the results of expensive function calls so you can reuse them when the same inputs occur again. A map is perfect for this because you can use the function input as the key and store the computed result as the value. Before computing a result, you check if the key exists in the map. If it does, you return the stored value instead of recomputing. This can make functions like Fibonacci much faster. Question: how do you create and use a nested map with 2 levels? A nested map is a map where each value is another map. Before you add data to the inner map, you must check if the inner map exists and initialize it if it doesn't. For example, with a map of countries to cities, you first check if the country map exists. If it doesn't, you create a new map for that country. Then you can add the city data to that inner map. It's safer to write a helper function that handles this initialization for you. Question: how can you get only the unique elements from a slice in Go? To get unique elements from a slice, use a map with empty struct values as a set. Loop through the slice, and for each element, check if it exists in the map. If it doesn't, add it to the map and also append it to a result slice. The map ensures you only keep the first occurrence of each element. This gives you a new slice with all duplicates removed. Question: how do maps work with JSON in Go? In Go, you can convert a map to JSON using JSON.marshal and convert JSON back to a map using JSON.unmarshal. When converting to JSON, the keys are always sorted alphabetically in the output. A nil map becomes the JSON value null, while an empty map becomes an empty JSON object with curly braces. When converting JSON back to a map, numbers become float64 values by default.
Question: what happens when your map keys are not strings and you convert to JSON? When you convert a map to JSON, all keys become strings, regardless of their original type. For example, integer keys become string versions of those numbers. If your key type implements the text marshaller interface, Go uses that custom string representation for the JSON key. This works because JSON only allows string keys in objects. Question: what useful functions for maps are available in Go 1.21 and later? Go 1.21 introduced the maps package with several helpful functions. Clone makes a shallow copy of a map. Copy copies all key value pairs from one map to another, overriding existing keys. Equal compares 2 maps to see if they have the same keys and values. Delete func removes entries based on a condition you provide. These functions make common map operations easier and more readable. Question: how can you convert a slice of key value pairs into a map? To convert a slice of pairs into a map, you can loop through the slice and add each key and value to a new map. In Go 1.23 and later, you can also use the maps.Collect function with an iterator. Both approaches create a map where each item in the slice becomes one entry in the map, using the key from the pair to look up its value. Question: what happens when you use a nil map in Go? Using a nil map is safe for some operations, but not others. You can get the length, which is 0. You can delete a key and nothing happens. You can loop over it and get 0 iterations. You can read a key and get the 0 value. However, if you try to write to a nil map, the program will panic and crash. Question: can you get a pointer to a value inside a map? No,
You cannot take the address of a value stored in a map. This is not allowed because when a map grows, it moves its data to new memory locations. If you had a pointer to a value, that pointer would become invalid after the map grows. Go prevents this problem by not allowing pointers to map values at all. Question: in what order will items be printed when looping over a map? The order is not defined. When you loop over a map in Go, the items can appear in any order, and the order can be different each time you run the program. Go intentionally randomizes the iteration order to prevent programmers from relying on any specific sequence. Question: what happens if two Go routines try to write to the same map at the same time? If two Go routines try to write to the same map at the same time, the Go runtime detects this and crashes the program with a fatal error. This happens even without using the race detector tool, because Go has built-in protection against concurrent map writes. To avoid this, you must use synchronization like mutexes or sync.Map. Question: can you store functions in a map in Go? Yes, you can store functions as values in a map. The map keys can be any comparable type, like strings, and the values can be function types. This is useful for things like dispatching different operations based on a key. You can look up a function by its key and then call it immediately.
Question: can you use the cap function on a map to check its capacity? No, you cannot use the cap function on a map. The cap function only works on slices, channels, and arrays. When you create a map with an initial size hint, that hint is used for internal optimization, but there is no way to read that capacity back. You can only get the current number of items in a map using the len function. Question: how could you compare two maps in Go before version 1.21? Before Go 1.21, you could use reflect.deep_equal to compare two maps. This function checks if both maps have the same keys and matching values. However, deep_equal treats a nil map and an empty map as not equal, even though they behave the same in many ways. With Go 1.21 and later, the maps package provides a better equal function for map comparison. Question: how do generics make map functions more flexible in Go? With generics in Go 1.18 and later, you can write reusable functions that work with maps of any key and value types. For example, a merge function can combine multiple maps of the same type. A filter function can create a new map containing only entries that match a condition. A map values function can transform all the values in a map to a new type. These generic functions work with any comparable key type and any value types, making your code more reusable.
Question: what changed in Go 1.24? Starting with Go 1.24, the internal implementation of maps was changed to a Swiss table design. This change makes map lookups about 15 to 30% faster and uses memory more efficiently. The way you write code with maps remains exactly the same. The improvement happens automatically when you upgrade to Go 1.24 or later, with no changes needed to your programs. Question: is it safe to use a map inside the init function? Yes, it is safe to use a map inside an init function because init functions run sequentially in a single Go routine before the main program starts. There is no concurrency at this point, so no race conditions can occur. This makes init functions a good place to set up maps with initial data that will be used later by the program. Question: can you declare a map as a constant in Go? No, you cannot declare a map as a constant in Go. Constants in Go must be known at compile time, but maps are dynamic data structures that are created at runtime. Instead, you can use a variable with a map, or for immutability, you can write a function that returns a new copy of the map each time it is called. Question: when you assign a nil map to an interface, is that interface equal to nil? No, it is not equal to nil. When you assign a nil map to an interface variable, the interface holds a type and a value. Even though the map value is nil, the interface has a type, so it is not considered nil. This is a common trap in Go, not just with maps, but with any nil value assigned to an interface. Common mistakes. Map versus other data structures.